Hello, good morning everyone, and welcome back to the Kia Ora Theatre at Linux.conf Australia 2022. I hope you had a great morning tea, and I hope you had a great rest, and I hope you have a great rest of your day. Our first talk today is Steve Ellis, who is an open source technology evangelist in the APAC Office of Technology team at Red Hat, and a regular face around LCA and the rest of the community as well. This session is going to look at a couple of different approaches for creating our standard images, with ImageBuilder for our traditional Linux images and Buildah for our container images. It's all yours, Steve. Take it away.
Hey, thanks, Caitlin, and thanks everyone for joining me. And I'm really pleased to be giving this session after this morning's keynote because the term ephemeral was referenced. And I actually put up on the first slide one of the definitions, because some people say, well, what do you actually mean by this? And well, I think ephemeral really is a great way of referring to the way we should be treating a lot of our environments and a lot of our platforms today. So look, well, we'll dig into this as we go through the session. Please use the questions tab, and I'll try and come back to them at the end, or I'll jump into the Q&A area after the talk. So here's like a rough agenda. We're going to kick off with a bit of the why and a little bit of history. We're going to dig into the what is the technologies that we're looking at today, ImageBuilder and Buildah. And then a bit of the how. And we're actually going to do some live demo because, you know, this is a conference. I love doing live demos. And then a little bit of a look back. Did we get to where we wanted to be? Did we actually answer some of the why? And I actually think some of the why isn't so good after listening to the keynote this morning. I think Liz did a much better job of summarizing some of the reasons why these tools are important, and why these approaches are very, very important to the way we should be dealing with environments today. So, ephemeral. Terry Pratchett's one of my favorite writers of all time. And this is a terrific quote that appeared in The Guardian a few years ago. Death appears to have some sneaking regard and compassion for a race of creatures which to him are as ephemeral as mayflies. And that really nicely positions it. There may be a few more Terry references as we go forward. So why are we having this conversation? Let's be honest, security is hard. It's incredibly hard. We're living in a landscape where every day, every week, we seem to have new security compromises and issues. But to counter that, change is hard. It's really hard to convince customers or organizations to change. It's incredible the number of times where I've seen a security fix delayed for an inordinate amount of time because of change management. The change is critical, but the change has to still go through the process. For many of us, cloud has changed the way we do everything. Almost everything, because not everything runs in the cloud. We have to deal with more than just cloud environments. And consistency and repeatability are difficult, can be difficult, shouldn't be difficult, because we're dealing with a mix of environments. Many of us are dealing with physical and virtual workloads. We're now dealing with cloud instances, and we may be dealing with containerized workloads. And I'm not even getting into things like serverless. And then we've got all those legacy things that we have to deal with. You know, a number of organizations are dealing with edge appliances, legacy appliances, and now everyone's going on about the future of IoT. And how do we make sure that we have that consistency and resiliency and the security we need for managing all those environments? So let's step back a little bit and look at a bit of history. Let's look at an environment that's very long-lived. There isn't a lot of change over time. In fact, you thought it was difficult changing the time on the clock radio in your car. Imagine adjusting this for daylight savings. It's relatively repeatable, but it's an amazing engineering effort to put up. This isn't something that you're going to easily repeat because of the cost of producing it. Let's step forward a little bit into the realms of mechanical computing. And honestly, if you ever have the chance to visit the Science Museum in London, go and look at this because it is stunning. I think this is a piece of art. But it's a very, very mechanical device. It is repeatable, but it requires a high degree of engineering. Customizing it, hard. Changing it in some way and program it isn't overly easy. And then we step forward a little bit to Turing machines, and I really want to visit Bletchley Park next time I'm in the UK and go and have a look at this as one example of an early Turing machine. Again, mechanical devices that you put one wire wrong, you make one that you've now impacted your programming. That the nature of the devices is there's a high rate of things going wrong. And when we step into digital computing, we now have a high degree of control. It's easier to load the operating system. It's easier to load the software. These are big hulking devices that weren't really subject to the high rates of change that we need to deal with today. And they're anything but ephemeral devices. I actually got introduced to the need for ephemeral computing fairly early on, thanks to this man and this device. Clive Sinclair's ZX81 and the infamous RAM packs that we had. There's a few things I learned that were really important in my early years of programming with the ZX81 and later a ZX Spectrum. First of all, the importance of backups. Backups are critical. Backup and recovery was something you really needed when, with one wrong move, your RAM pack would wobble and you would lose all your data. Everything you did was ephemeral. I also learned the vital importance of a well-placed piece of Buildah. So stepping forward, how do we install software? Install the operating system. In the case of my ZX81, it was from a cassette tape, the humble cassette tape. Stepping back in time, we had things like paper tape or punch cards. These aren't exactly reliable. It's very easy to damage them. And in fact, if you have a look at the links below, Command Line Heroes Season 4 from Red Hat really digs into some of the history of computing and some of the early methods for loading software. Coming forward a little, we move through floppy disks, through CD, DVD, media, and now into USB keys. They're all ways we used to bootstrap systems traditionally. So when I was thinking about this talk, I kind of stepped back and said, well, really where we're going to get to now is what we should be talking about is infrastructure as code. And I realized way back in 2008 at linux.conf, I actually gave a talk about infrastructure as code. This is part of the sysadmin mini-conf, and it's quite amusing actually going back and re-looking at this talk. So I've actually provided the links here to some of the presentation materials and the original video. But while we're in that session, we talked to the need for reliable, repeatable, reproducible infrastructure, effectively infrastructure as code. We talked about some of the technologies available back then around whether you should use system imaging versus technology like Kickstart or Pre-Seed in order to build up your base operating system. We want to make sure the way we were doing this was abstracted away from whether the system was physical or virtual. There was the options around patching versus rebuilding systems when we were dealing with operating system updates. Security and hardening was still just as important, if not more important, back then. So we looked at capabilities like operating firewalls and SE Linux, etc. And then back then, the post-build automation tools we were looking at were things like CF Engine and Puppet. Ansible hadn't come along at that stage. And I couldn't underestimate the importance of having things like single sign-on. Making sure out of the box that we've got the environments integrated with our identity management is incredibly important. So that was all the way back in 2008. My role's changed many times since then, and I spend a lot of time talking to customers and operations teams about how they build and run systems. And surprisingly, or unsurprisingly, these are still two of the most popular ways for systems to be bootstrapped in a lot of enterprises today. The number of times where it's still sticking a USB or even sometimes a DVD in a system in order to bootstrap it is just incredible. And there's still an enormous amount of systems out there today which are click, click, click through the installer rather than automating the delivery and having your corporate customized approach to delivering those services. When we talk about cloud computing, containers, and modern workloads, we often use the terms pets and cattle. I'm going to use some different terminology here today. I want to talk about snowflakes and dwarf axes. Because a snowflake is extremely fragile. A Snowflake system is very, very hard to change. You may change one thing and the whole Snowflake collapses. Snowflake systems are usually created and left to live for a long time with very little change or modification. Dwarf axes are incredibly robust. Again, another Terry Pratchett reference. See, a dwarf axe may have been in your family for decades, may have been in your family for generations. It's had 8 new heads and 7 new arms, but it's still the same dwarf axe. Now, if we apply the dwarf axe thinking to systems, a good system, a good service should be like a dwarf axe. It should be resilient, it should stay up, it should be hard-working. But we should be able to change its underlying infrastructure. We should be able to change its head and change its arm without actually the service changing. And to be honest, I have a personal dwarf axe. And again, this is a reference back to linux.conf in 2008, because I talked about the development of a MythTV-based PVR appliance. Now, my own unit is actually kind of the dwarf axe I had all the way back in 2008. I've changed the operating system many times. I've actually swapped it from 32-bit to 64-bit versions of Linux. It's had many motherboard iterations and CPU iterations. I've changed the hard drives. I've changed the tuners. And yet, it's still the same dwarf axe. It still has recordings from all the way back in 2006. It's still providing the same service. But I've abstracted away the configuration and data from the underlying infrastructure. That's a really important change that started to come through in a great part by cloud computing, the arrival of cloud computing. And another big change that came through with cloud computing was the conversation change between dev and ops. Because traditionally in many organizations, there was a great big wall, there was a divide. You know, there was that running joke that dev would throw something over the wall for operations to manage. And once they started to conversate, once they started to collaborate, those walls started to come down. And today, most organizations also introduced security into the conversation. Now we have the term DevSecOps. And boy, is that something we really need today. I mean, I apologize for any PTSD flashbacks here, but how many of these can you name? You know, because there was a period where every week there was a new super vulnerability. Every week there was a vulnerability where the logo, the branding, the website for the vulnerability was better than that for the originating project. For those of you who can't remember them, we've got Heartbleed, OpenSSL, Shellshock, which was a bash vulnerability, Poodle, which was again a SSL vulnerability, Stage Fright, which was a big Android vulnerability, Drown, which was another SSL vulnerability, and then Badlock, which was a Samba SMB vulnerability. And Badlock was a big deal. I mean, they spent so much time warning everyone that that existed in the IT ecosystem long before it was kind of made public so that we could put some mitigations in place. So having dev, ops, and security talk to each other really started to change everything. So I like to say dev met ops and started to talk about security. We're now seeing the need for greater consistency in environments because greater consistency drives repeatability. We want consistency across our stack. We want the same stack that for our developers to run as we're running in production. We don't want the same surprises we used to have in the past where the developer environment had a completely different library, a completely different operating system release. And the move towards containerization has really helped that because developers can work on the same environment, the same base environment as we're really running in production. But speed of delivery has changed. Long gone are the days where we're waiting months for new infrastructure to arrive in the data center, waiting weeks sometimes for an operating system to be deployed onto it. Maybe days for allowed to get access to a system. In fact, I know a few organizations where even when they try to automate the process for standing up their infrastructure on virtual hardware, it was still taking weeks because several steps involve people as a service. Once they reduce that down, and found ways to automate around some of the firewall rule changes, DNS allocation, some of those other steps. They now got it down to hours. And pretty soon they had it down to minutes. And then suddenly the business is expecting seconds. And if you're working in a containerized ecosystem, you start to get used to that incredible speed of delivery. We need it right now. Because ultimately, businesses expect faster delivery than they did in the past. Cloud has changed this. So there's a little bit of background of where some of my thinking's gone, some of the conversations I've had over the last 12, 13, 14 years since linux.conf 2008. What are we here to talk about today? We're going to talk about two projects, two capabilities that kind of focus on solving two parts of the problem. ImageBuilder, with the upstream project osbuild, is focused on creating operating system images. Buildah is focused on the container side of the story, and Buildah is there to create OCI compatible container images. So we're going to dig into each of these in turn, and then we're going to do a little bit of a demo. So ImageBuilder or osbuild. ImageBuilder effectively represents some of the US UI components for osbuild. So it has a web UI that plugs into Cockpit. So it's called Cockpit Composer, and you can access it through the Cockpit web interface. It also has a command line interface, Composer CLI, and something that Red Hat's been developing for its customers is actually a SaaS type service, which means that our customers can come in and actually just go and request ImageBuilder to be run on their behalf to create their custom images on our backend platform. osbuild, what kind of does all the heavy lifting, has a RESTful API, and then the workers that do all the actual composition. Now, historically, some of this was based on Lorax Composer and components out of the Welder project, and the API is still based on the Welder API. So the RESTful API comes out of Welder. osbuild-composer is kind of like a reworking of the original work that went into Lorax Composer. So it's been, now I've forgotten the word. Anyway, we'll move on. Here's a high-level view of the architecture. So we've got on one side the user interfaces, the CLI or the web UI. They then communicate with osbuild-composer. That they run locally on your machine or on the machine that's got the web UI, and then they will kick off the jobs, and then you can have a pool of workers. And this is one of the strengths of this, is that you can actually have different workers targeting different operating system flavors or targeting different architectures. So this is the current supported list of architectures from typical x86 through ARM, Power, and System Z. This is quite a nice pluggable architecture, so it should be relatively simple to extend it to other platforms as they increase in popularity. One other nice part of this is the image upload capability. So you can just have it generate an image and then you can pull it down either through the command line or the web interface. But you can actually provide credentials and have it automatically push an image into Amazon or Azure if you're using that for your cloud-hosted workloads. So each platform, each target platform has a set of standard packages and requirements. So at the moment, we can target AMI for Amazon and VHD for Azure. We have VMware VMDK, generic QCOW2, OpenStack, and we have an IoT-based image that's based on OS tree commits. One of the reasoning behind this is that OS tree gives us a nice way to do kind of A/B testing or rollout, so we can actually have the old iteration and a new iteration of our image on a system. We can push out a new image and then have the system flick to it. Architecture-wise, as I said earlier, at the moment, we currently support 4 architectures. So that's just some of the capabilities in ImageBuilder. Looking at Buildah, Buildah is part of our attempt to kind of break down the capabilities available today in Docker. So where Docker kind of attempts to be an all-in-one tool for running containers, building containers, providing an API, the container standard originally. Podman is our way to provide an OCI compatible runtime. Scopio is there for container image management, and Buildah is there just as a build tool. Now, by separating these services out, it reduces the attack surface. These are each just focused on a particular capability. It means that you can actually, and we do have an example in the Git repository I'll share with you during the talk, of a simple OS image that can only run containers. It can't build them, which is a great thing because you don't want someone building custom containers on your production container host. Also around containerization is some standardization around runtime interfaces. So we've now got a CRI-O standard. So as long as your runtime supports CRI-O, and CRI-O has very much been engineered with a focus around Kubernetes, then any containers built to work against CRI-O will work against your runtime, which means you can have a choice of different containerized runtimes. If you really want to dig into a lot more around how containerization works and some of the underlying capabilities, I recommend you have a look at Fraser Tweedale's talk from yesterday. Now, Buildah is there to, as I said, provide those OCI compatible container images. And it can do multi-stage builds with and without Docker files. And this is really cool because you've got several ways of actually engineering the way the build comes together. And I think also from a security perspective, very importantly, you can build container images as a non-root user. I think that's incredibly important. And something I talked about last year was like running containers as a non-root user. It's equally important to be able to build containers as a non-root user. So let's get into a bit of the how. So there's a Git repository here. I'll share it in the chat later. What we're going to use is it's got all of the demo code, all the scripts I've used to help stand this up, and it's actually got a walkthrough of how to run some of this demo yourself. We're going to use ImageBuilder and Buildah, and we're going to actually run all this on a Fedora host to keep it all free and open. And in the vein of keeping it ephemeral, I'm actually going to spin up a Fedora Cloud-Ready image that's running on my local laptop. So it's running on KVM QEMU using libvirt. And then I use a small Ansible playbook to customize it to install the required components. So again, all this is in the Git repository. So you've got access to all of this. You can go and try it all out yourself. So the ephemeral host means I can create it, run it for the purposes of this talk, and then tear it all down again and then use it again at a later date. So first, we're going to bootstrap our QCOW2 image. So we're going to use a standard off-the-shelf Fedora 35 cloud image. I've also tested this with RHEL 8.5 and RHEL 9 if you want to play around with enterprise flavors of Linux. And then we're going to do the installation of Buildah, ImageBuilder, and also Cockpit, because that's a key requirement. Now, this is the fun bit. Because it's a demo, there may be a few shortcuts. Most of these cloud-ready images don't allow SSH as root, and it's just an easy way for the purposes of this to do things quickly. So I customize the image, I stripped out cloud in it, and I set the root password to password. Isn't that awesome? If you're going to run this on a cloud image hosted in Azure or AWS and try it out there, I recommend you don't use password as your default password. Also, if you want to try this out, there's a hosted version that we make available completely for free at Red Hat of both ImageBuilder and Buildah. These are hosted labs that you can actually just go and walk through and try some of this out today for free without ever installing anything on your local laptop or spinning up a cloud image. So let's just spin over to a shell. Because of time, I've actually had to do a couple of tasks early. So you can see my date and time now, it's just 1:10. But I set this up at 10 o'clock this morning. So here's the script, which is actually in my Git repository. So here's the Git repository. This has all of the guidance and then how to deploy and run all the steps. So here we're going to deploy a local or cloud hosted image, and we're going to set a few values, and then we run the script. And this basically takes the cloud-ready image and just creates a snapshot of it. We then customize that snapshot and set the password to password. Very naughty, but what the heck. And then we run virt install to create a VM off it that we can access on my local laptop. So that's what we've done here. And then we can see we've examined the guest. This is actually the customization step. And we've uninstalled a package and we've tweaked SSH config and set the passwords. Now, the second part of this, there's a guide there also for doing this on RHEL 8.5 if you want, is the Ansible setup. So in this case, you simply need to run a Ansible playbook and it does the rest of the setup for the demo. So here's that part where we log into the host. We make sure it's not running RHEL, so we don't need to subscribe it. We enable Cockpit, ImageBuilder, Buildah, set up firewall D correctly, firewall rules, install Git, and we clone our repo. So we've actually got a copy of this repo with a few extra files available as part of this demo and walkthrough. We've now got a environment ready. We're now going to show off some examples of using ImageBuilder. So let's jump back to my web browser, and here we go, and we'll log in to our ephemeral environment. So I'm going to log in as root. There we go. So here within the cockpit UI, I have an ImageBuilder option. And I have no blueprints. Blueprints are the baseline for this. Each blueprint defines one of our images. Blueprint can be customized for an OS version. And there's a whole series of different customizations you can walk through. So I'm going to create a web server blueprint. And what this now going to do is it's going to go off and see what packages are available that can go include into the blueprint. Now, this will just take a few minutes to sync. One other option, I jump back to my instructions of this step, which is here. This tells us what we're going to go and add package-wise into that image. It's loading, they're still doing a sync. But there's some extra commands here. So I can do things like, if I look on the command line, I can see, here's my Fedora image. If I do that, I can see that this version of ImageBuilder is capable of producing the following types of images. Likewise, I can start and stop jobs and do a bunch of other things through this. This is still syncing. Joy. I should have gone through this step slightly earlier. Right, so now I can go and do things like add HTTP, search for HTTP. And B. And I can add, here we go. And when I add that, it's automatically going off and doing a dependency lookup and making sure I need to pull in 187 dependencies. Now, for the moment, I'm not going to go through all the extra steps. I'm actually just going to commit this image because I want to show you some of the other parts of the web UI that are available. Now, I'm not going to create the image at this point. I'm going to go back. I haven't set a host name. I'm going to give it a host name. And then I can go and create an initial user, which I'm going to call webmaster. I'm going to make it administrator, and I'm going to give it a really hard to remember password, which of course is password for the sake of the demo. So I can now see what packages I've got. I've got no images created, but I can now go and say create an image, and I can go and say what type of image I want it to create. Great. Now, there's a few things here to be aware of. It will do dependency checks. I can also do a dependency check on the command line. So I can go compose list, blueprints. List. And I can also have a look. Find the right. Sorry, I need to, oops, name the show web server. And there's my definition. So I've actually got a web server definition, HTTPD name, and the password inserted. Now, one thing I've done here is I've actually got a customized version I can push to replace this. One nice thing is that the version, the blueprints are versions. So if I look at the version I've actually got saved locally, this does a little bit more. So it actually does the firewall setup. So I've customized the firewall settings. It's also made sure that the services start. Now, one thing at the moment through the web UI, you can't specify which services you want to start and stop. You need to do that through the command line. I've also inserted an SSH key, and I've also put a few extra packages in. So if I do this, and then have another look, I've now got the updated image. And if I jump back into my web UI here, do a forced refresh, one problem I've found is that the UI doesn't always refresh so quickly, but this will now come up and it's got all of the packages I need. Now, what I'm going to do now is generate an image I can deploy. And I'll do that here on the command line. So what I'm going to do is I'm going to create a QCOW2 image, and that will come back shortly with a UUID for the image that's being created. And I can actually just take a look at, so if I use my instructions and go, and then, so these are all the instructions that are in the Git repository. So that job started. That's going to take about 4 or 5 minutes to run. So let's actually dig into some of the detail while that's running in the background. So that's actually now how we can define and create an image definition. Looking at the blueprint we've got, I'm not specifying any versions here. So I've made this blueprint very OS independent. I can actually reuse this blueprint to create a Fedora image or a RHEL image or a CentOS image or other platforms, but because I haven't been explicit around what versions of packages and components I want or which OS I'm building for or what architecture. But there's things you can override here if you want to tune that. For the purpose of the demo, it's quite nice to be able to show the same thing running on multiple platforms. The other thing you can do, as I said earlier, was be able to upload your generated images automatically to AWS and Azure. So this is just how you would configure a identity file that's got your access keys for those platforms, and then you simply include that when you're starting the compose, and it will automatically create the image and push it up for you into the cloud platform that you're using. So this is going to take a few more minutes. Let me have a look at that's still running. So while that's running, let's have a look into a few of the issues. So one of the things here you can do is compose a CLI blueprint dep solve. Dep solve is really useful. It allows you to check that you've validated all the dependencies associated with a particular image. Depending on the platform you're targeting, there may be specific additional dependencies. It doesn't quite catch everything I've found. For example, one of the other examples I've got in my Git repository is creating a simple Podman-based container host. It needed an extra dependency that the dependency checker didn't pick up because the QCOW target enforces SE Linux, and it then added another dependency that didn't come through the dependency model. So that's a bit of a bug, something that we need to kind of dig into and look at. So I've already tagged that there. And of course, the web UI sometimes needs a bit of a refresh, forced refresh if you're doing things through the command line. And there's a few gaps around features. Really, the web UI is a great way to get things started or to do some simple blueprint definitions initially. If you're really going to be a power user, you really need to get into customizing those TOML files yourself. So I think this is still running, and if I jump back to the web UI and go to images, and unforce refresh, no, it's not showing up there yet, but we'll leave that running and we'll dig into the next part of the talk. Now, Buildah, we're going to use the same host VM, and we're going to step through a few examples of building containers using Buildah. So if I jump back up here and come down and go to try out Buildah, there's again the guide on how to get started with this. So we're going to jump into this location. And I've got a few Docker files, a few Docker build files here and a few other examples of how we can build containers using Buildah. So if I jump into UBI minimal, look at the Docker file, this is a real simple stripped back example of a web server. Now, I'm actually using here our UBI 8 minimal instance. Now, the Red Hat UBI instances are freely redistributable. There are universal base images. We patch them and maintain them, and they've got access to a reduced set of packages that you can again also use for free and build into your container images. So you can actually build off this on a Fedora host without any Red Hat subscription, without paying any money to Red Hat, and use this as part of your projects. So I can actually just build. Now in this example, I'm basically creating a very, very simple web server. I'm injecting a index and I'm simply running HTTP in the foreground. I'm not putting any additional customizations in. So I'm going to build using Dockerfile, and that's going to kick off and pull. Again, this is a completely clean environment, so this is doing a fresh pull. So hopefully my internet connection is good enough of the UBI minimal image, and then it's going to use micro DNF because this is a micro image. We actually don't have full fat YUM and DNF in there. It uses a thing called micro DNF. This is one of the smaller image types that we make available. So there we go. That's fairly standard kind of build for anyone who plays around with containers. And now you can see that we've got the baseline image from Red Hat and our UBI minimal. I can double check this is working using Podman. So I'm going to start that service on port 8000, map that port internally to port 8080. I can see that that's running. Awesome. And now I can run a simple curl command and get back that response. Awesome. I can also do all the usual things around looking at the logs, which is pretty much nothing, so I haven't set anything specific into the container that I'm running today. So what I'm going to do now is simply pull that one down and show another example. So if we step back here, we've got another way of deploying pretty much the same thing, slightly different approach. So if I look at this is building off the same baseline image, but we're building without using a Docker file. So this is kind of producing the same output. So if I run this now, we don't need to pull the image because it's already down. We're going through much the same steps. And if I do images, you can see now I've got two different web server images. They're roughly the same size, but been created using different methodologies. And again, I can start that one. I can run curl, and then I can also just pull it all back down again. One other nice thing that we've done is in the container world, there's a lot of contention about image sizes and small images. So we actually have an even smaller example now. I'm running short on time, so I'm not going to dig into this right now. So, but hopefully, I've got my, where are we? I'm in the right window. I've now got that QCOW2 image, and I can now go and download that and run that locally, and I will get my web server instance up and running. Now we're running low on time, so there's a few things. Alternatives. ImageBuilder, you can look at things like Packer. That's very popular. EC2 image builders, there's cloud-specific ones. You can, of course, still use things like Kickstart. I still use that a lot. Builder alternatives, you've, of course, got Docker. BuildKit and Canco are out there today. BuildKit's come out of Moby as kind of an equivalent, I think, to Buildah. We've got things like S2I, which kind of act like supersets. And you've got a lot of extra features. ImageBuilder versus Buildah, they're really apples and oranges because you're doing different things. One is all about the container. The other one is about the operating system. Lightweight, heavyweight. You know, and when people go on about image sizes, there's a really good article done by Scott McCarthy about comparing different types of image sizes. Don't get hung up on it. If it's a really big deal, you can use things like the UBI minimal example, a UBI micro example. Again, that's in my code repository. Go and have a play with it. At the end of the day, by the time you've actually built the container with your services, often there isn't a big difference between the different baseline OS instances. So ImageBuilder is really about full OS images, infrastructure agnostic, version blueprints, whereas Buildah's very much focused on that single app service and needs an OCI runtime in order to make it work. But they're all open source and they all focus on that important thing about infrastructure as code. They give us consistency and reliability. Bit here on the roadmap. One big thing in the ImageBuilder space is looking towards OCI support so that the OS tree layers map onto the kind of OCI model rather than the existing OS tree model, and better dev tool integration. Buildah, again, a chunk of work going on upstream on that. Few gaps and issues, pain points. Trying to drop Buildah sometimes into existing CI/CD tools that expect Docker is not much fun, but it's getting better. It's getting much better. So why have we been doing this? Well, security is hard, but I strongly believe infrastructure as code helps change everything. Cloud has almost changed everything, but we're not everything's there. Let's be honest. I don't run everything in the cloud. Neither do most of my customers. Some people are all in, some people aren't. But we need to have that consistency and repeatability. And this is where these tools are great because the blueprints are text, therefore it's infrastructure as code. It can live in a source code repository. We can version it, we can manage it. And hopefully, when the next big security vulnerability comes along, we can be ready to deal with it. Because there's always one more vulnerability. There's almost one more thing to patch. And those old vulnerabilities, well, they're still lingering somewhere in the background. If you've got any questions, I'll answer them because we're running short on time. There's a load of references here and background material. As usual, my slides will be posted up on my people page at Red Hat. And again, all the content's available on GitHub. So thank you all for your time.
Thank you very much for your talk.
Right.
We've got about a minute for questions. We've got 3 questions in the queue, and the leftovers will go into the text chat, of course. That was a really good walkthrough of some really practical ways to use those tools. So thank you so much for that. I think the most interesting question in this list, I think, is can the image builder roll Fedora Silverblue-ish images with its OS tree support?
Yeah, that's kind of what the IoT model does. If you play with it on RHEL 8.5, and I actually have a RHEL 8.5 instance here with, if I do composer, if I check the image capabilities here, it's got a bunch of extra ones compared with Fedora at the moment because there's work we're doing around additional composability models. So yeah, there's some work happening in that space.
That's really cool. I think we'll take the rest of the questions into the text chat. Thank you so much for your talk, Steve. Have a great rest of your conference.
Thank you, everyone, for joining the session.
Thank you. The next talk that we've got coming